Hello, this is William from Visual Components. In this video, I'm going to show you how to control a picker robot. In this case, we're using a Delta robot to pick and place parts on the same conveyor. Now in the 3D world, I have a layout open, which you can find a link to in the video description. So open that layout, and if you run the simulation, you can see that this feeder creates these blocks at a random offset and orientation. So once the blocks reach the sensor, your goal is to teach the robot to pick the block and place it back on the conveyor with the right orientation. Now this is an exercise for the Control Robots tutorial available in our Visual Components Academy. If you need to go to the Academy, you can click the Help tab here, click the Academy button, this opens a web browser, and takes you to the Visual Components Academy, which you can see here. So if I click Lessons, scroll down, here's the Control Robots tutorial, and I do recommend you complete this tutorial before starting this exercise. I'll now exit out of this, and you have a couple options. You can either complete the exercise on your own, or you can follow along with me. Just know a couple things first. Let's reset the simulation. I've already wired these signals in the sensor conveyor to the robot. So if I go to the Program tab, select the robot, select the Signals checkbox here, you can see that the sensor Boolean signal in the sensor conveyor is wired to port 100 in the robot, so it's an input port. So the robot knows when a part reaches the sensor. I've also moved one of the native tool frames in the robot to the position of an imported tool frame here in this gripper. So if I go to the jog panel and set tool to tool data 0, you can see that here's the tool frame that I'll be using. So all you need to worry about is just writing the Python script. And let's go ahead and get started. So I will clear the Signals checkbox here, go to the Modeling tab, and you can either put the Python script in the sensor conveyor or in the robot. In this case, I'm using the robot. So go to the Behavior group, click the Behaviors arrow, and then add a Python script. And notice when I added the behavior, it opened the script editor for me. I'll make my text a bit bigger for you. There we go. And the next thing I want to do is import vchelpers.robot2 module or library in our Python API. So say from vchelpers.robot2 import everything, and that's what this asterisk sign means. Now if you need documentation for this module, you can go back to the Help tab, and in the Help and Reference group here, just click Python API, scroll down the contents, and here's the topic, and here's the documentation. Notice you have to use a constructor here to create a robot object that can be used with this library. So we're going to do that now. I'll close this out, and I'm going to use the onRun event, so I'll say define onRun, robot equals get robot. Now I can use this without passing any argument because the script is contained in the robot. So if I print this out, it should be a new instance of a robot object. So if I run the simulation and stop it or reset it, you can see in the output panel, yep, I do have a VCRobot2 object. Let's now modify our script to know when a part reaches the sensor. So I'll use a while loop in my script. So I'll say while robot.signal map in. This gives me the Boolean signal map behavior in the robot that's used for its inputs. And we use a method called input. And this allows you to test the value of a port in the robot. So the input port of 100. So as long as that input port is not true, I'm going to keep on checking it until it's true to break out of this loop. And once that's done, let's go ahead and print a message in the output panel. So part is ready to be picked up. So I'll compile the code, run the simulation. Here comes that first block, and let's see what happens. Yep, so now the part is ready to be picked up. Let's reset the simulation. And now we need to know what part needs to be picked on the conveyor. So this will be a bit tricky. Let's go ahead and create a list called picked. And this will just be a list to know what we picked on the conveyor. Let's now get the conveyor object. So I'll say app equals get application, and I will use that to find a component in the 3D world. So in this case, I'm finding the conveyor. It's going to be app.findComponent, and I need to use the conveyor's name, which is sensor conveyor. So there's a space there. And now I want to know what components are attached to the conveyor or on its path. So if I actually print out print conveyor dot child components, this will return a list. So if I clear the output panel and compile my script. After a part reaches the sensor, I'll then print out the list of components that are attached to the conveyor. So it should be a couple. Here comes the block, trigger the sensor, and right now we can see there are 2 parts on the conveyor on its path, and that's the number of items in our list that was printed in the output panel. But remember, we now have to teach the robot to pick this first part here. So let's go ahead and reset the simulation. We don't need to print this anymore. But we are going to get that parts list. So say parts equals conveyor dot child components. And you could use a for loop. You could say for part in parts, if part is in our picked list. So if we know that the part has already been picked, we don't want to pick it again. So we're going to remove it from our parts list. So I'll say parts dot remove part. And then we'll go ahead and get the first part that we want to pick. So I'll say part equals parts dot pop, which will return an item in the parts list. Now we don't want to stop the conveyor, we just want to pick the part while it's moving on the conveyor. So we're going to use a method called pickMovingPart in vchelpers.robot2. So I'll say robot.pickMovingPart, and we want to give it the component we want to pick. In this case, it's our part variable, or part object. So now if I compile the code, we expect the robot to pick the part when it reaches the sensor. So let's rerun the simulation. Here comes the part, excitement, and yeah, the robot picked the part. Great. So now we need to place it back on the conveyor. So let's reset, and then we'll use a method called robot.place. And in this case, we're going to place it on the conveyor, so we just need to give it as the first argument. So I'll compile the code, run the simulation, and now we expect the robot to pick the part and place it back on the conveyor. And there you go. And notice that it placed it back. If I stop the simulation, it placed it back with the orientation that we're looking for. Now, of course, you can pass additional arguments to the place method to kind of, change the orientation of this block, but this is the orientation I want for this exercise, or you can make the orientation however you want to, but this is fine for me. But notice that if we reset the simulation and run it again, we'll notice what happens. The robot picked a part here, but then placed it back on the center of the conveyor. So we need to apply some type of X offset to make sure the robot picks and places the part kind of at the same location of where it started from, or where it picked the part from. So let's reset the simulation. And now we need to go to our script, and we need to know what the robot actually has picked up. So we know that the part is no longer in the conveyor, so I'm going to say part equals robot.graspContainer. And this is a container in the robot that's actually containing that picked part during the simulation. And if we say robot.graspContainer components, that will return a list of components that are in this container. So the robot right now is only picking up one part, so we can just get the first item in the list. And then we want to get the position matrix of this part, so I'll say POS equals part. And instead of getting the position matrix, which will refer to its parent coordinate system, I'm actually going to get the world position matrix of the part. So world position matrix. And in this case, I just want the vector. So we'll keep our offset simple. I'm then going to get the diagonal of the conveyor. So I'll say A equals conveyor dot bound diagonal. In this case, the conveyor only has one node, so this diagonal is referring to that root node. And then we need to get the offset in the x-axis, so let's say offset x equals POS dot x minus a dot x. So I'm getting the world position matrix, or position of the part. In this case, I'm returning the vector, the position vector of that matrix. I'm then getting the bound diagonal of the conveyor, which if I zoom out just a bit in the 3D world, it's going to go from the component's origin of the node origin to about here, about midway point, or it should go from the center to that way. So it's going to give me that x-axis offset. I'm then minusing the position of the part, its x-axis, from the conveyor's x-axis to give me an offset. So now, if I place the part with that offset, so I'll cut that statement and insert it after I get the offset, I'll now pass the translate x argument, my offset value. So if we want to make this a bit easier to understand, what I'll do is let's actually first compile the code and see if this works. I'll run the simulation and zoom in for you. Robot picks the part, and yep, it's now working out. So if we reset and run it again, notice that it's going to pick the part and place it back at right about the same location with the correct orientation. And yep, that's what we're looking for. So if you're a bit confused about what I did here for the vectors and the offset along the x-axis, I'll go ahead and print out these values. So I'll say print pos.xValue, print, actually let me do that at the end. So after everything is done, so I'll say print pos.x, print a.x, and then print offset x, which is this value subtracted from this value. Or sorry, this value is subtracted from this value. Let's compile the code, run the simulation again, and I think it should probably be about 100 or so, I'm not sure. It'll vary per component. So if I now stop the simulation and look at the output panel, the x-axis of the part that was in the robot's gripper container was about 853. The conveyor diagonal x-axis, so basically from here to here, or to the center point where the sensor is, was about 750. In this case, the units is millimeters, and the offset was 103.25. But this will vary per part depending on where the robot picks the part from the conveyor. So let's reset, and we don't need these lines of code anymore. So after we pick a part, we want to add it to our picked list. So let's insert that after we pick the moving part. So I'll say picked.append part. Then after we place the part, we then want to go back through our pick list and check that if we've picked any parts that are no longer on the conveyor, we can go ahead and remove them from the picked list. Now in this case, instead of using a for loop, I'm going to use the filter method in Python, or the filter function. And if you need more information about that function, you can go to the Help tab, click Python 2.7. This will open the Python version 2.7 documentation, and notice that we do use a stackless version of Python. Now go to search and do a search for filter, and this should be in data structures because it's affecting lists. So if I scroll down, you can see here's some documentation for what that function is doing. So what the filter function is going to do, it's going to return a list of items that match a certain condition. And in this case, our condition is that the picked part is still on the conveyor. So we can compare it to when we want to pick the next part on the conveyor. I'll X out of this, and then go after we place the part. I'll use that picked list I'm working with. I'll use the filter method. I'll use a lambda operator to inline the expression, so lambda x. So this is the object, and if that object is in the conveyor, so if it's attached to it, I'll use conveyor.childComponents, which is the same thing that I did in this line of code here. I'll then add it to the list, and that list that I'm checking those objects in is our picked list. So notice here, we added the part that we picked to our picked list, and then after we place that part, we're then going to assign a new list to our picked variable that contains elements that we've already picked that are still on the conveyor. They're still attached to it, and that's what this expression here is doing, or this condition is saying. So now let's create a big loop for picking many parts. So let's get our application object, cut that from here, paste it there, and now write one big while loop. So while app.simulation.isRunning is equal to true, what do we want to do? Well, we want to do all of this. So I will select all this, press the tab key, and now I have my while loop here. So while the simulation is running, the robot will wait for the sensor to be triggered by a part. And after the part has reached the sensor, let's leave a comment here. Part reach sensor. We're then going to get the parts that are in the conveyor or attached to its path. So in this case, you could cut this out of your main while loop and put it up here if you wanted to. That's fine. But during the simulation, we do need to check, each time what components are attached to the conveyor when the sensor is triggered. So here we're getting the parts, And then we're checking if we've already picked a part, we don't want to pick it again, so we're removing it from our parts list. And then we can have a list that just contains the parts that have not been picked yet, and we're getting that part that we want to pick. We're then telling the robot to pick that part, so pick part, and add to our picked list. Then we're going to place the part back down with the right orientation, basically about the same position where we picked it on the conveyor. So we're going to place the part back on conveyor. Notice here we're getting the part's position matrix, its position vector, and then we're applying an x-axis offset when we place it back on the conveyor. We're then checking our picked list of parts on the conveyor. So if the part is still on the conveyor, when we loop back to check the parts that are on the conveyor, we want to know if we've already picked them, and that's why we're doing this line of code here. So what we could do the same thing of using that filter method to clean this up. So we could say, after we get the, or before we get the part list, we could say parts equals filter lambda x for that object. So the object is picked. So if the object is not in picked, then we want to add it to our parts list. In this case, the objects are coming from the conveyor.child components, or what this property returns, that list of components attached to the conveyor. And I don't want to confuse you, so what this line of code here is doing the same thing as this line of code here. So we actually can comment that out if we want to. So I will use a multi-line comment here. Because we're filtering the list of child components in the conveyor, and we only want the items in that list that are not in our picked list, because we only want to pick the parts that have not already been picked. So if I compile the code and clear out my output panel and run the simulation, what we expect to happen is the robot will just pick and place multiple parts. Let's see what happens, and I did make a mistake. So on line 7, I referenced the conveyor before I got the application object, so I apologize for that, but I'll keep it in the video. And there we go, that fixes that. Clear the output panel, compile the code, and please, I want to see that magic. Here we go. Picks the part, good. Picks the next part. I like what I'm seeing. Do you like what you're seeing? Yes! Alright, there we go. This concludes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.